Hi students, this class we are going to discuss about the other product. Earlier we discussed about the scalar product of two vectors. Now we are going to discuss about cross product. That is nothing but vector product. A bar, B bar, these two are non-zero vectors inclined at an angle theta. Then their cross product in that order. Their cross product, that means A bar cross B bar, in that order is denoted by A bar cross B bar and is equal to magnitude of A bar into magnitude of B bar into sine theta into n cap, where n cap is a unit vector perpendicular to the plane of A bar and B bar in such a way this A bar, B bar, n cap forms a right-handed system. Just observe here, this is A bar and this is B bar. This is the direction of n cap. Now this A bar, B bar and this n cap forms a right-handed system. So this is A bar and this is the direction of n cap. A bar, B bar and this n cap forms a right-handed system. Actually this n cap is not on the board. This is the direction of n cap. Right? So that is about the definition of A bar cross B bar. Now A bar cross B bar is a vector whose magnitude is mod A bar mod B bar sine theta. That's why I can write magnitude of A bar cross B bar is equals to mod A bar into mod B bar into sine theta. Now suppose here A bar cross B bar is equals to 0 bar, then we can write either A bar is a 0 vector or we can write B bar is a 0 vector or we can write A bar is parallel to B bar. Cross product is equal to 0 bar means they are either A bar is a 0 vector or B bar is a 0 vector, or we can say those two vectors are parallel vectors. So now what can you say about I cross I? I cross I is equal to 0 bar, that is equal to J cross J, that is equals to K cross K. Right? But what about I cross J? According to this we can write I cross J is equals to magnitude of I into magnitude of J into sine, or this is sine 90 degrees into a unit, because this is along x axis, this is along y axis, angle between x axis and y axis is 90 degrees and this is the direction of z axis. That's why along z axis the unit vector is k cap. That's why we can write I cross J is equals to k. So that's why we can write in this way I J, next one is k. So I can say I cross J is equal to k, J cross k is equal to I, k cross I is equal to J. So if you are following the cyclic order means I cross J you will get k, J cross k you will get I, k cross I you will get J. Suppose you are reversing the cyclic order, I cross k is equal to minus J, k cross J is equal to minus I, J cross I is equal to minus k. So with the help of this, now we can find out the vector product in terms of its component. One vector A bar is given as A1I plus A2J plus A3K. The other vector B bar is equals to B1I plus B2J plus B3K. Now I can write A bar cross B bar is equals to determinant of I, J, K, A1, A2, A3. The next one is B1, B2, B3. So that is about A bar cross B bar. But now A bar cross B bar is not equals to B bar cross A bar, but we can write that is equal to minus of B bar cross A bar. A bar cross B bar and B bar cross A bar, they are not equal, but A bar cross B bar is equal to minus of A bar cross B bar. Now what is the geometrical interpretation of cross product of two vectors? Two vectors cross product geometrical meaning we are going to discuss. So these are the two vectors represented along the two adjacent sides of a parallelogram. This is A bar and this is say B bar. Now this is equals to angle between the two vectors. Let us say that is equals to theta OAB. So OACB is a parallelogram. Now what is the definition of A bar cross B bar? A bar cross B bar is equals to magnitude of A bar into magnitude of B bar into sin theta into n cap. Right? Now from this diagram, from the point P onto OA, a line is drawn perpendicularly. Let us say this one as M. Now from this diagram what we can write? Sin theta is equals to BM divided by OB. From this I can write BM is equals to magnitude of B bar into sin theta, because OB is nothing but this length. That length is nothing but magnitude of B bar. So magnitude of B bar into sin theta. So in place of magnitude of B bar into sin theta we can write BM. In place of magnitude of A bar we can write the base OA. OA into BM is nothing but base into height. Base into height is nothing but area of the parallelogram is multiplied with n cap. That's why we can say A bar cross B bar is represents the vector area of the parallelogram with A bar and B bar as adjacent sides. So magnitude of A bar cross B bar is nothing but area of a parallelogram with A bar and B bar are adjacent sides. But if A bar, B bar are the adjacent sides, then the area of the parallelogram is given by magnitude of A bar cross B bar. Now observe here, what is the area of this triangle? The area of a triangle OAB. Area of a triangle OAB is nothing but the entire parallelogram area divided with 2. That's why half into A bar cross B bar. Parallelogram area divided by 2, you will get the area of this triangle. A bar and B bar are the two sides of a triangle represented in magnitude and direction by the two sides of a triangle. Its area is given by magnitude of A bar cross B bar. Okay, so that is the area of a triangle. Now just one question I am asking here. A bar, B bar are the adjacent sides of a parallelogram, then its area is given by magnitude of A bar cross B bar. Now the question is in this way. What I am asking in the question, this is, we don't know, let us say this is a B bar and this one is equal to Q bar. Now what is saying in the question is, this is one diagonal represented by A bar, this is another diagonal represented by B bar. A bar comma B bar are the two diagonals of a parallelogram. What about its area? Tell me now, according to the parallelogram law of addition of vectors, what we can write? P bar plus Q bar is equals to, no doubt, P bar plus Q bar is equal to A bar. Right? At the same time, Q bar plus B bar is equal to P bar or not. That's why I can write P bar minus Q bar is equals to B bar or not. Now add these two, you will get P bar is equals to A bar plus B bar divided by 2. Now subtract these two, you will get Q bar is equals to A bar minus B bar divided by 2. Now observe here, P bar and Q bar represented in magnitude and direction by the two adjacent sides of a parallelogram. then its area is given by magnitude of P bar cross Q bar. But what is a P bar? P bar is nothing but A bar plus B bar divided by 2 cross A bar minus B bar divided by 2, right? So that we can write it as 1 by 4 into A bar plus B bar cross A bar minus B bar. Now again this we can write it as 1 by 4 into A bar cross A bar 0 bar minus A bar cross B bar, next plus B bar cross A bar, next minus B bar cross A bar. So total it becomes 2 times A bar cross B bar in magnitude divided by 4, that is equals to 1 by 2 into magnitude of A bar cross B bar. So magnitude of A bar cross B bar divided by 2 is the area of a parallelogram. Earlier A bar B bar represent in magnitude and direction by the two adjacent sides of a parallelogram. Its area is given by magnitude of A bar cross B bar. Next, now A bar B bar represented in magnitude and direction by the two diagonals of a parallelogram. When A bar B bar are the diagonals of a parallelogram, its area is given by half into magnitude of A bar cross B bar. Now another discussion here is 3 points given whose position vectors are A bar, B bar, C bar. This is a triangle. This point position vector is given as A bar, and this point position vector is given as B bar, and this point position vector is C bar. Now what is the area of this triangle? Yes, here also the area of a triangle is given by half into magnitude of BA bar cross BC bar. That is the area of a triangle. This is one side, this is another side. BA bar cross BC bar, magnitude is the area of a triangle. Yes, we can also write BC bar cross BA bar also, because it is a magnitude, it makes no difference. Now area of a triangle is given by 1 by 2 into BA bar is nothing but A bar minus B bar, position vector of A minus position vector of B, cross BC bar means position vector of C minus position vector of B. Now I can write this one as 1 by 2 into A bar cross C bar minus A bar cross B bar minus B bar cross C bar plus B bar cross B bar. Now I can write this one as 1 by 2 into A bar cross C bar. I am writing it as a C bar cross A bar with a minus sign, minus A bar cross B bar minus B bar cross C bar. Now we can take minus common, it is in magnitude, it makes no difference. That's why 1 by 2 into magnitude of A bar cross B bar plus B bar cross C bar plus C bar cross A bar. That is the area of a triangle. A bar, B bar, C bar represent the position vectors of the vertices of a triangle. A bar, B bar, C bar are the position vectors of the vertices of a triangle ABC. Then its area is given by half into magnitude of A bar cross B bar plus B bar cross C bar plus C bar cross A bar. That is the area of a triangle. If these 3 points are collinear, then this value is becoming 0. That means magnitude of A bar cross B bar plus B bar cross C bar plus C bar cross A bar is equals to 0. At the same time, observe here, from this point A onto this, we have to find out the perpendicular distance. How to find out the perpendicular distance? That perpendicular distance is given by half into magnitude of C bar minus A bar, half into base into height is equals to area of a triangle. What is the area of a triangle we got? Area of a triangle is equal to half into A bar cross B bar plus B bar cross C bar plus C bar cross A bar. Both sides half cancel. We will get H is equals to magnitude of A bar cross B bar plus B bar cross C bar plus C bar cross A bar divided by magnitude of C bar minus A bar, that is the perpendicular distance from a point A onto the side BC. Okay, but what about this vector? A bar cross B bar plus B bar cross C bar, A bar cross B bar plus B bar cross C bar plus C bar cross A bar. What this vector represent? That vector represent a vector perpendicular to the plane of the triangle ABC. Yes, this is BC bar, this is BA bar. These two cross product we are finding, but these two cross product means this is the direction or not. So that's why it represents a vector perpendicular to the plane of ABC, right? Where A bar, B bar, C bar are the position vectors of the vertices of the triangle ABC. So one more question, or I can say it is a property type. Just I am discussing. Observe here. A bar cross B bar plus C bar is equals to A bar cross B bar plus A bar cross C bar. That we want to prove, right? Because it is given in the NCERT textbook also. A bar cross B bar plus C bar, that means distributive. Okay, so how to prove this one? First of all, we require to find A bar cross B bar plus C bar. Observe here how I am doing. First of all, what is A bar? Okay, I read on I, J, K. A bar components are A1, A2, A3. But what about B bar plus C bar components? B1 plus C1, B1 plus C1, next B2 plus C2, next B3 plus C3. Now last row is the sum of two elements or not. That's why we can express it as sum of two determinants I, J, K. Last row is the sum of two elements. That's why we can express it as sum of two determinants. The first one is B1, B2, B3, and the next one is C1, C2, C3. Second row we are not disturbing, that is A1, A2, A3 only. Now tell me what we can write this one as. This is nothing but A bar cross B bar, and the next one is nothing but A bar cross C bar. So that's all. That is the way to do this particular question. So let's discuss another question here. So the another question is given in this way. What is a vector perpendicular to the plane of A bar comma B bar? What is a unit vector perpendicular to the plane of A bar comma B bar? A bar comma B bar. A vector perpendicular to the plane of A bar comma B bar means it is nothing but their cross product or not. This is A bar and this is B bar. Now this one represents a vector perpendicular to the plane of A bar comma B bar. But we require a unit vector perpendicular to the plane of A bar comma B bar. That's why I can write A bar cross B bar divided by magnitude of A bar cross B bar. This is a unit vector perpendicular to the plane of A bar comma B bar. This is the vector perpendicular to the plane of A bar comma B bar. Sir, you are asking a vector perpendicular to the plane of A bar comma B bar. That's why we can do this opposite direction also. That's why this represents plus or minus A bar cross B bar by magnitude of A bar cross B bar represents a vector perpendicular to the plane of a unit vector perpendicular to the plane of A bar comma B bar. So another question you can see here. The question is given like this, which we will call it as magnitude of A bar cross B bar whole square plus magnitude of A bar dot B bar whole square is equals to mod A bar whole square mod B bar whole square. That is nothing but cos square theta plus sin square theta is equals to 1. So this same thing, because here we know that sin square theta plus cos square theta is equals to 1. Now here what I am doing is mod a bar whole square mod b bar whole square into sin square theta. Next one is mod a bar whole square mod b bar whole square into cos square theta is equals to mod a bar whole square into mod b bar whole square. Both sides we multiplied with mod a bar whole square into mod b bar whole square. Now this is nothing but magnitude of a bar cross b bar whole square. The next one is a bar dot b bar whole square, and this one is magnitude of a bar whole square into magnitude of b bar whole square. This is nothing but the Lagrange's identity, right? Mod a bar cross b bar whole square plus a bar dot b bar whole square is equal to magnitude of a bar whole square into magnitude of b bar whole square. This is Lagrange's identity, better to remember as a standard results. Next one, the question is given like this. So very beautiful question. If x square plus y square plus z square is equals to 1, then he is asking the maximum value of 2x minus y whole square plus 3y minus 2z whole square plus 3x minus z whole square. So if you know an idea, next time definitely you will get an idea how to proceed. Observe here what I am doing. I am taking a bar is equals to xi plus yj plus zk. Observe here 1, 2, 3. 3y minus 2z, 2x minus y, 3x minus z, all the terms are there. So that's why I am taking the other vector b bar is equals to I plus 2j plus 3k. Now you can check those two cross product. That means a bar cross b bar is equals to determinant of I, j, k. Here we have to write x, y, z and b bar 1, 2, 3. Now tell me what about these two cross product. I into 3y minus 2z minus j into what you will get 3x minus z plus k into 2x minus y. Whether you observed or not, all the terms are appearing here. 3y minus 2z, 3x minus z, 2x minus y. But what we know, magnitude of is asking to x square plus y square plus z square is given 1 and 2x minus y whole square, 3y minus 2z whole square plus 3x minus z whole square minimum value is asking. What we know, magnitude of a bar cross b bar whole square is always less than or equals to mod a bar whole square into mod b bar whole square. That is the known information, because sin square theta less than or equals to 1. That's why you will get magnitude of a bar plus b bar whole square is always less than or equal to mod a bar whole square into mod b bar whole square. But magnitude of a bar plus b bar whole square means this vector magnitude square. Then what we will get? 3y minus 2z whole square. Next 3x minus z whole square plus 3x minus z whole square. Next 2x minus y whole square is less than or equals to mod a bar whole square is nothing but x square plus y square plus z square, that is mod a bar whole square, into mod b bar whole square is nothing but 1 square plus 2 square plus 3 square. In the question this information is given as 1. X square plus y square plus z square is equals to 1. That's why this value is always less than or equals to 14. That's why its maximum value is equals to 14, right? So this is another question. The question is given in this way. A bar is given as a bar is equals to 3i plus 2j plus 4k, and b bar is equals to I plus j plus k. It is meaning is I cap plus j cap plus k cap, and c bar is equals to I plus 2j minus k, and he is saying r bar is any vector. We have to find out the vector r bar. R bar is any vector in space such that r bar is perpendicular to a bar given R bar is perpendicular to B bar also given. And also given the information R bar dot C bar is equals to 5. That is the information given in the question. What is saying in the question? So this is the vectors. One vector is A bar. This is another vector B bar. You know very well. This is the vector. The pen which you are observing. This is the vector R bar. R bar is perpendicular to A bar. R bar is perpendicular to B bar. Observe here. R bar is perpendicular to A bar. R bar is perpendicular to B bar. But now this is the vector A bar cross B bar or not? How R bar and A bar cross B bar both are parallel or not? Yes or no? R bar and this is A bar cross B bar. These two are parallel. So R bar is perpendicular to A bar. R bar is perpendicular to B bar means R bar is parallel to A bar cross B bar. R bar is parallel to A bar cross B bar. That means R bar is equal to lambda times A bar cross B bar. Now I can write this one as lambda into I, J, K, 3, 2, 4, 1, 1, 1. Right? So you will get lambda into, so that is I into 2 minus 2, that's why minus 2, minus J into minus 1, 3 minus 4, next plus K into 3 minus 2 is 1. Right? So this is R bar we got. But the information given in the question is, because we have to find out lambda value. For finding the lambda value, the other information given in the question is R bar dot C bar is equals to 5. That's why this is R bar. This one dot product with the C bar, you will get 5. From there you will get the value of lambda or not. So lambda value substitute here, you will get the desired vector R bar. So another question here. Now the question is saying, Ka bar is equals to 3B bar plus 2C bar, and next A bar is equals to minus 2B bar plus 5C bar, such that C bar and B bar have opposite directions. C bar and B bar are the vectors are opposite direction. That is the information given. Okay, then what to do? So I can write K into, in place of A bar, minus 2B bar plus 5C bar is equal to 3B bar plus 2C bar. Observe here what I am doing. Now I can write this one as 5K minus 2 into C bar is equals to 3 plus 2K into B bar. Right? So therefore I can write C bar is equal to 3 plus 2K divided by 5K minus 2 into B bar. He is saying these two vectors are of opposite direction. C bar and B bar are two vectors having opposite direction. Opposite direction means definitely this value we have to get negative or not. So that's why 2K plus 3 divided by 5K minus 2 must be less than 0. Now wavy curve, this is equal to minus 3 by 2, and here we have 2 by 5 plus minus plus. Less than 0 means we have to consider the negative portion. That's why K belongs to open interval minus 3 by 2 comma 2 by 5. For these values of K, these two vectors B bar and C bar are in opposite direction. So this is the another question given here. OA bar is equals to L1I plus M1J plus N1K. Next OB bar is given as OB bar is equals to L2I plus M2J plus N2K. That is OB bar. And also saying that L1, M1, N1. L2, M2, N2. Those are the direction cosines of the vector given, or otherwise they have given the information magnitude of OA bar is equal to 1, magnitude of OB bar is equals to 1. Array its magnitude is equal to 1 means L2 square plus M2 square plus N2 square is equal to 1. Its magnitude is equal to 1 means L1 square plus M1 square plus N1 square is equal to 1. That means L1, M1, N1, L2, M2, N2 are the direction cosines of those two vectors or not? Yes. So that is the information given. Then he is asking the direction cosines of a vector along the internal angle bisector through O in OAB. So this is OAB. This is one vector OA bar and this is another vector OB bar. So we have to find out the direction cosines of this one. But how to find out? As we know, let us say this one has some A bar and this is equals to B bar. How to find out a unit vector along the internal angle bisector? The unit vector along the internal angle bisector is A cap plus B cap divided by magnitude of A cap plus magnitude B cap. This is the unit vector along the internal angle bisector of A bar and B bar. Now A cap plus B cap, already these are caps only. This is a unit vector, this is a unit vector, these are already caps. So that's why what I can write this one, L1 plus L2 into I cap plus M1 plus M2 into J cap plus N1 plus N2 into K cap, right? So whole divided by square root of L1 plus L2 whole square plus M1 plus M2 whole square plus N1 plus N2 whole square. So angle between them is also given as a theta. Angle between these two vectors is also given as theta. Right. Now what about this simplification? We will get L1 plus L2 into I cap, M1 plus M2 into J cap plus N1 plus N2 into K cap by under root. What about this simplification? L1 square plus M1 square plus N1 square, you will get 1. L2 square plus M2 square plus N2 square, again you will get 1, plus 2 times L1 L2 plus M1 M2 plus N1 N2. But what we can write this one? Yes, that can be written as L1 plus L2 into I cap plus M1 plus M2 into J cap plus N1 plus N2 into K cap by square root of, that is 2 plus 2 times cos theta. Agree or not? The angle between these two vectors, angle between these two vectors is nothing but these two dot product. These two dot product is L1 L2 plus M1 M2 plus 1 N2 only. By its magnitude is 1, its magnitude is also 1. That's why L1 L2 plus M1 M2 plus N1 is equal to cos theta only. That's why we got this one. Now what we can write? If you take 2 common, 1 plus cos theta is equals to 2 cos square theta by 2. That's why direction cosines I am writing, because it is a unit vector. Direction cosines are L1 plus L2 divided by 2 times cos theta by 2. Next, M1 plus M2 divided by 2 times cos theta by 2, comma N1 plus N2 divided by 2 times cos theta by 2. These are the direction cosines of a vector along the internal angle bisector. Similarly, for external angle bisector, what happens? External angle bisector means A cap minus B cap divided by magnitude of A cap minus B cap. You will get minus, you will get. That's why here minus 1 minus cos theta is 2 sin square theta by 2. That's why L1 minus L2 by 2 sin theta by 2. m1 minus m2 by 2 sin theta by 2. n1 minus n2 divided by 2 sin theta by 2. That's what we will get for direction cosines along the external angle bisector. So these are the few ideas discussion in vector product. So more few applications I will discuss in the next class based on this dot product and cross product exclusively applications. Okay, bye bye.